Hi. Hi everyone. My name is Tavish, and I am the co-founder of Analytics Vidya. Let me give you an introduction about myself. So I started my career with Kunal Jain. Kunal Jain was my manager in Aviva Life Insurance. So the task was that to create the buy-in from the stakeholders and create a business analytics arm for Aviva Life Insurance. So we worked together. We created a lot of strategies, and after around 2 years, I moved on to a new role with Citibank in Bangalore. And initially, I was responsible for retail banking industry, where we used to develop a lot of retail banking models, and we used to find out what are the right transactions, how to move customers to a digital platform so that we can save some expense. And after that role, I took a new role called Next Gen Analytics, where this was a very R&D oriented team, which was more to do with new technologies which we can use as a bank, something which we have never used before. Something like if you have shopped at Amazon, you probably would have seen that tab called recommended videos, recommended products in Amazon, recommended videos on YouTube. So why not do something for banking as well? So what we did was pretty interesting. So we have a lot of transaction coming from customers, very similar to Amazon. Let's use that data to really go to the next level and pitch them new products, new offers. So you walk into a new mall, say UB City Mall in Bangalore. I exactly know where you are in UB City. I know that I have a tie-up with some bank, and this is a product which you might be interested in. Let's try to push you to that product and make your life easier. And we try to help customer make better choices. So those were the kind of models we used to work with Citibank. So these are something which banking industry have never seen. So we started working on big data platform, and then we realized that what potential it has. So we'll talk more about big data, machine learning, which I started learning in that phase of my career. And given that this was like 4 years back, 3 years back, so this was pretty new to banking industry. So we faced a lot of hard time to find out the right content, and then is when we took the task that let's educate our audience with machine learning and what it really is and what kind of potential it really has. So in this entire workshop, this is what our focus will be, to give you a quick course on how this machine learning is changing the industry and what it really is and where does it really fit in. So we hear a lot of words like big data, machine learning, but we will really talk about what they really are and are they even related to analytics industry or not. So this is how was in Citibank. Then I moved to US, City US. Right now I am heading the operations analytics for Citibank, where we are answering some of the key questions which banks are really struggling with. So the biggest cost center for any banks is the operations cost. You call up the call center, we take up those phones, and this becomes the biggest expense for us. And to cut down this expense is not really worth doing, because this is the only interaction we have with the customer. So we are trying to optimize that interaction so that the customer experience is seamless, but we optimize to on cost to whatever extent it's possible. So apologies if I face a few technical challenges in the meanwhile. Uh, uh, so we will just start up with the session. So here is our initial question to answer. What do you really think analytics is? Tell me all the words which comes to your mind when I say analytics. And you can use the chat window for that. Okay. Uh, I'm future, visualization, predictive. Yes. Let's now narrow our focus to what are the things which you will use in analytics. We will talk about something like big data, machine learning. What have you really heard? Tell me more about uh, what have you heard in machine learning, what you have heard in big data. Uh, Obviously, it's a future, understanding data, data exploration, learning from data. Great. So I think you get the idea that these are all the jargons we hear. Let's make sense out of them, that what they really are in this industry. Do we really use them? So for instance, I hear that let's apply big data into this problem. We will talk about this more, that big data is not a tool which we can use, but it's just a platform. Machine learning is baked onto the big data. So I will put up my first poll question to understand my audience better. uh, Kunal, is it possible for you to launch my first question, the poll? Yes.
Yeah, I've just.
uh, okay, thanks, Kunal. Which of the following is not related to business analytics at all? Big data, machine learning, and hypothesis generation. And which of them do you think? Okay. Uh, can we stop the poll and see the results? Okay. None. That's so accurate. And I think my audience is someone who already knows what machine learning, big data is. So let's talk more about this. Uh, as of now, we use machine learning. Machine learning is a tool which we use to basically uh, crack down a problem. So if we already have a business problem, the first step always is that you structurally define what the problem statement should be for the analytics, and then you attack that problem with a machine learning algorithm. And this entire thing should be executed on a big data platform if your data is huge. And just to give you an example of huge data, as of now, I work with call center data. Now, call center data are recordings of these calls. Imagine that something like 100 calls will be a 5 GB data, and we get around 7.5 million calls in a month. And any analysis is not complete until unless we have like 6 months of data. So this is what we are talking about: 6 months of data into one something like 7.5 million calls into something like 5 GB by 100 calls. So that's the kind of huge data we are dealing with, and we push this into an environment where we use machine learning. So this is what the uh, this is all about. So it includes all the three which we just mentioned, and you are right. So it includes all of them. So let's get more to this topic, which is what is predictive model. Uh, yes. So predictive model is simply a tool for predicting the future using the historic data. So I have been reading a lot on a book called Predictable Irrationality. This is by Dan Ariely. So what he says is that we think that every choice we make is very irrational. We think that we are making a random choice. However, this behavior in human is very predictive, and this is what we try to break. If that data has some value, you can make out predictions. Let's talk more about the kinds of prediction you use on a daily basis. Let's talk more about, so two example which comes to my mind is Google Maps. Google Map is a huge simulation. I enter the on my phone that I want to reach here. It gives me a prediction that 60 minutes is all you will take to reach that location, and there is rarely a moment it is wrong by more than 5%, even though the dynamics are so changing that traffic jams, there are accidents on the road, and there are times when the traffic will fluctuate. But imagine that over that 60-minute window, it almost always knows what will really happen on the road. So how can they be so sure about it? So this is what prediction is. So there are a series of prediction which goes into Google Maps, and then is when it says that this is the amount of time. And imagine the kind of data they are aggregating. They are aggregating it for everyone, and everyone's feedback gives them a clue that how much time you will really take. So the second example which comes to my mind is weather forecasting. So you exactly know what the temperature is today, and based on all the trends and all the kinds of behaviors, like the wind is flowing in this direction and the temperature near you is falling down. So all these inputs goes into a weather model, and they finally create that prediction what will be the climate in your location, and they do this for every possible location. Imagine the kind of data they are dealing with. Now it's a question for you: what are those few things which you have observed till now in your daily life which you think is basically done through some kind of prediction? Tell me on the chat window. Oh, there's some challenge with the PPT. Uh, are you able to see my presentation now? Okay, I'm getting a lot of replies. I feel matches. Recommendation while online shopping, recommendation at online shopping sites, YouTube recommendation, targeted ads. Awesome. So you already know what it really is: stock trading, targeted ads. So what you will observe in all of these is, say for example, food partner restaurant. That's a very good example. So for instance, we see that there is some behavior which we show. For example, I am very impulsive while buying something, but Amazon exactly knows what I want to buy. So we might think that we are so irrational, we are making a random choice, but they are not really random. And there is significant data on me, which makes me very predictable. And that is what we try to use. We try to use that behavior, that all the data which I have has a lot of value, and hence let's make prediction out of them on a customer level. So if you think of the journey analytics has gone through, and Kunal will second me on this. So we used to create segment level models. When I used to go behind a segment and I used to say that this segment is very profitable, let's target them. Now we went on a granular level, we now are on customer level, that let's go on a customer level. For every customer now I have an exact probability, and let's try to really target through those probabilities. Now it's even going granular when you are talking about simulations, what Google Map does. So a lot of things which you have mentioned here, stock trading, Google simulation, these are all aggregation of prediction. It's not a single prediction they're making so many prediction at the same time, and all of them get collated together, and there is single simulation which runs, which basically simulate how you will behave in future, and then they will try to find out what is the best choice for you. So Facebook friend recommendation, that's again a very good example. So these are different predictive models which we come across on our daily lives. And I just wanted to confirm, are you able to see my screen to 100% or again 65%? Before I move on to the next slide. Okay, perfect. I see no from. Okay, so I think most of you are. Okay, perfect. So let's move on to the next phase. Now we know that we are really affected by analytics all around the world. It is touching us from different ways. You are getting weather forecast. You are getting recommendations. Now it's always a debate whether it's a good thing or bad thing that they know so much about us, but they definitely make us happy because they make us make better choices. So that is what we do uh, in any industry you take. So there are a few things which I mentioned here. How much money do we lend to our friend? How the decision that which route should I take? Now this was a very difficult decision. If we never had a clue that what is the traffic condition in a road, we exactly know that how much time it takes by covering so much distance, but there are so many other factors which a human brain cannot process, and machines are really good at this. And with our machines becoming so much better, this is a much easier problem to be solved by machines and not humans. So that is why now we rely on these machines to make these decisions, and that is what is making our daily life so much better. uh, let me ask that philosophical question. I know that it's a philosophical question. Do you really think they are making our lives better or not? Or do you think that it's fun to work on this data, but it's not really good that they know so much about us? Okay, I'm getting mixed response, but slightly tilted towards yes. That is correct. So evolution is never wrong. That is correct. Depends on our perspective. That is also correct. But what I believe is that until unless your choices are being impeded, it is always good. So if Amazon is giving you a recommendation, if Google is saying that you are going to say New York City and you probably should go to a restaurant, and I give you this offer, and I know that I'm already going to a restaurant, why not try this? It gives me an offer. I have in a way changed your behavior, but I have never forced you to go to that restaurant. So it's a win-win situation for all. So machines are making decisions only on those things where they are really good at, where humans do not have all the information. And through so much analytics, so much hypothesis testing, what has come out to be the case is that if you have infinite number of choices, you are never happy. If a machine can narrow it down to 3 or 4 which you really like, you are always happy because you have to make a better choice. So this is my understanding, that it always makes your life better until unless they come into your comfort zone. So uh, going back to the topic, so difference, the model building is a well defined process for building these predictive models. So we use these models, and modeling is basically something which is already defined. Now after machine learning coming into our industry, it's not really difficult to create models. What is more difficult is to understand the problem better. Find a way to take the problem from a very early stage, which is when you understand the business problem, to a stage when basically you have solved that problem completely, and now you exactly know what you need to do in terms of strategies. So model is just a process, a well defined process to build a predictive model. So I'm going to the next slide. Yeah. So there are some life stages of a model building. We will talk about most of them briefly, but I will like to focus so much more on these first two questions, which is problem definition, hypothesis generation, and data extraction, data exploration, predictive modeling, and model development. We'll focus more on problem definition and the hypothesis generation. Now, uh, let me try to pitch on another question on my screen. One second. Kunal, can you
Ramesh,
launch the second?
yeah, which one?
Okay. The second question, which is on machine learning and big data. This is just a
Sure.
question so that I understand that you got the concept, and you never confuse between these two. I have
Sure.
seen a lot of questions, and believe me that this is not something which someone who is completely unaware of analytics space, this is a question which I have seen across the board. Someone who is on a director level and he doesn't know what big data is and what machine learning is. So do you really think they're the same, or do you think they are completely different ideas? So is machine learning same as the big data analytics? And know that big data is big data analytics. I'm not talking about the big data platform. Okay, let's see the results now. Perfect. They are not same. I do agree. So as I said, big data analytics is only coming into picture if you have huge data. If you have trillions of gigabytes, terabytes of data, and sorry, trillions of gigabytes of data and huge data, and you want to solve that problem. So big data environment will just make that process easier and will make that happen. Before we went into a big data platform or big data structure, it was not even possible for us to basically attack these problems, the kind of problems Googles are solving. Uh, so, okay. So now coming to the problem definition, I believe that this is the most important step. When a business comes to you with a problem and then you define what the analytics problem is, which is hidden behind this business problem. So here I will take slightly different approach. I will put up a business case and my audience has to reply what the business problem is, or there can be so many variations of these business problems. Let's try to find out what are the right analytical problems to solve. So let's talk about a few things. So let me give you an example. I used to work in insurance industry. Your uh, your business comes to you as a problem. The problem is that it takes me 3 years to basically break even on a particular account. Now, if it takes me 3 years, I at least want my customer to stay with me for 3 years. But what I am currently seeing is that my average duration of an account, or someone I sell the insurance, the average duration he stays with me and after which he attrites is around 1.5 years. And hence I'm making loss with every possible acquisition. So I need to fix this business problem. Now tell me a business problem converted into an analytical problem which you will be able to solve. Tell me a exact target function which you can solve for, uh, which you will use machine learning on. And let's try to use the chat window for that. And let me know if the question is not very clear. Okay, we have a churn model. So I want complete questions. So I want to optimize XYZ in a 3 months window, or a complete question which should have a binary variable. I don't even want a continuous variable for this, which should have just a question as yes or no. Yes, we will solve it using a logistic regression. Tell me a complete business objective function, which is a target variable, which you will solve for using a lot of hypotheses. Okay, work on customer retention, renew or not. Okay, I'm looking for something more specific. I am getting a lot of no ideas. Binary, either yes or no. Yes, I'm talking about binary variables, which will be yes or no. It will only have two outcomes. Okay, target variable attrited divided by non-attrited. Okay, I still don't have a window on that. I don't know for how many months am I looking at. Okay, propensity of customer to churn before 3 years. Yes, that's a very good uh, um, definition which we can have. Okay, so the definition should be something like this. It should have a window defined, something like 3 years, 1 year, and whatever the window we think is true. So let's talk about 3 years, because my business wants me for them to stay at least for 3 years, and after 3 years I exactly know they are profitable. So my window should be slightly more than 3 years, but let's say we finally boil down to 3 years. And using this 3 year, we'll try to find out whether the customer really attrite in these 3 years or not. What we'll do now is we'll go back in time and we will find out customers who have stayed with me for 3 years. They will be my ones, which are my good population. And there will be a lot of customer in the same cohort which will not have stayed for 3 years and would have attrited in 1 year, 1.5 years, and hence they will be my zeros. What my model will try to do is basically find out that specific behavioral attributes that makes them stay with me for more than 3 years. Let me give you another example, which is an actual example which we have solved for in analytics.
Tavish, just to clarify to people here, so this model is basically at the start when we are acquiring customers. So you're trying to kind of do a future looking thing, that which customers would stay for 3 years or not. Yeah.
Exactly. Yep. Thanks, Kunal, for that. Okay, so I will give you a similar example, but this will be slightly more connected, as in. But this time I want you people to think of the target variable better. So, for example, I am currently facing a hiring challenge. My agents, which come to me, so I hire agents on a commission basis, and the break even which I get after hiring an agent is 3 years again. But what I see is that after getting all the training and after consuming my resources, an agent tends to attrite after 1.5 years. Now, I want to create a model through which I will try to hire new agents who will stay with me for more than 3 years. So now tell me a kind of problem you are talking about, the kind of target variable which you will be looking at. This is a very similar problem, but I think I will want more participation from the audience so that I understand that you have got. Okay. Okay. So that is correct. So attrition of customer or attrition of agents on a 3 year basis. Yes. Attrition of agents in 1 year. Yeah, that is also correct. So if you do not have a lot of data on 3 year, let's try to shrink that window to 1 year. Now, what I was trying to focus on is something which you will see here. So let me now take an example. I do understand that you get the idea. So this is how we define a problem. So here is a problem which we have solved before. So this is on a credit industry. So what we want to do is we want to improve the profitability of the credit card customer. This is what the business will come to you, and this is a bad problem to solve. Now, what we generally go through is a process in which we think about a lot of things and create a specific business problem. Now, in this case, we want to improve the profitability of credit card customer. So my good problem will look something like want to predict the default rate of customers over the next 3 months. Now, the big thing which I want to focus is 3 months. Now, this is something which you will try to optimize even before you get into this data. And you will optimize using all the business judgments. And once you find out a range, what you will do is you will narrow down further. Now, there is a trade-off which generally happens. Now, if you go to say 6 months, you probably will get a higher accuracy, but your coverage will go down. Or if you go down from three months, your exact opposite will happen. So there is a trade-off which we try to manage using this window. And this is very important to define a target variable. So now your target function will something look like want to predict the default rate of the customer over next 3 months. And now you will go back in time and say you fix your cohort in January 2016. Now you look at all possible customers which are already with you, and you will see that for next 3 months, which are the customer who actually defaulted. They will become your goods, and the rest of them become the bad. I do understand that good and bad are exactly opposite what we want them to do, but to just define the problem, one becomes my good, other becomes my bad, and then what I try to do is I go through a certain process, a structured process to find out the right hypothesis which can justify this behavior, which is my next topic. Uh, okay, so let's talk about hypothesis testing. And before I will go to the hypothesis testing, I will put up a question here. Uh, so in terms of hypothesis generation, what do you really think is the right stage to do a hypothesis generation? Is it before we see the data, we do the exploratory analysis, or is it after the exploratory analysis? And the question is on your screen. So when do you really think is the right time to do hypothesis generation? And before looking at the data is before you even know what the data is with you. So you exactly know that I'm trying to solve the previous problem which I showed you on the last screen, which is I want to know that what is the rate at which customer will default in 3 months, and what are the possible hypotheses which can affect it. Let's find out those possible hypotheses, all possible hypotheses which can affect my behavior. So what do you think? Behavior before looking at the data, after looking at the data, or once we have collected all the data and know it all well? So what is the right stage? Okay. Can we see the results? Okay. Before looking at the data, after looking at the data, and okay. So there's a mixed opinion. Now, this is about the best practices and what we have followed throughout our careers and what we generally recommend. It is generally before even looking at the data. And why we say that is that looking at the data brings a lot of bias. Now you already know what is available, what is not available, what trends can you look at, what trends you cannot. So there are a lot of biases which comes into you if you basically see the data before you actually attack that problem. So it is always recommended that you do this process much before you look at the data. Now, to do that, for example, if I want to predict the default rate of the customer, I know that a lot of you might not really have a lot of background from the banking industry, but if you just have to give it a shot and think about all possible hypotheses, just put it on the chat window. What are the behaviors which can influence these customers? Uh, for distinguishing good from bad. Okay, monthly income, number of members, utilization. Okay, that's nice. Civil score. Okay, DTI. Okay, credit history, previous defaults, customer job types. Yes. So now you know that it is really possible that now you have come up with so many different hypotheses just because you do not know what the data really is behind the screen. So if you are talking about a new bank, a lot of these data might not be available. Now, if I would have shown you the data before asking you this question, what will really happen is you will have a lot of constraint in your mind. that I am a new bank and hence I do not really have the customer behavior, right? So and hence that's there's a question. Some hypothesis can be framed after seeing the data. That is correct. So it is an evolving process, and hence you can add more hypotheses, but the elimination should not happen on the first stage. It should always be with a bucket list of hypotheses, and then is when we go to the data and understand what is available, what is not available. If something is not available, can we find that out in the industry? Can we go beyond our behavioral data or our industry data and find it out from some other resource? So that is the right structure to approach. And if you see that you did miss out something and there is something which is available in your data, then you are always free to add it. But elimination should not happen on the first stage. Okay. Here I will pause for a moment and I will ask if you have any questions before I move ahead.
I think,
Okay.
Tavish, you can
Yeah.
probably spend a minute to help people understand why hypothesis generation is important. If you want to do it later, that's also fine.
Yeah, sure. So, okay, why the hypothesis generation is what is important in the entire process is that now if you really go ahead with the data, you always know that there are a few input variables and there is a target variable which you have already defined, and you want to build a model to bridge the gap from the input variable to make that prediction. Now, why hypothesis generation is always something which is important is that there are a lot of hidden things in that input data which you can create as features or new things which can really predict your target variable. So this is why we start with this hypothesis generation. And when you are going to this hypothesis generation, you generally go on a whiteboard and you think about all possible things which can really influence my target variable. And if you think about it, the things which we want to focus more is that all the hypothesis generation creates a holistic view. So you are able to capture everything. So if I have to think about the kind of variable which I am looking at, uh, you can talk about behavioral variable, which you have already put on the screen. There can be demographic variables, which can create hypothesis around, say, if I want to find out the agents which will not attrite in next 3 months or 3 years, I might want to understand what is the gender, what is the age band, or what is the income of that behavior, or something like uh, where does he belong to? Does he belong to Delhi NCR? Does he come from a faraway home? Or all those things which can affect him in terms of demographic. There are psychological variable as well, which can come out of surveys. So these are the types of holistic view you need to create to really come up with a extensive list of hypotheses for which you will try to predict your target variable. The second thing which you definitely need to focus is without a personal bias. So this is a normal problem we generally face in our industry. So we know our industry so well that there are a lot of personal biases that this is something which will never affect my behavior. But you cannot say that until unless you have proven it. So, and it is also possible that in machine learning, the variables can work with other variable to become a stronger predictor. So there should not be a personal bias in terms of selection of these variables, which can come through your industry knowledge or anything else. So in the initial hypothesis creation, you should be unbiased and you should think of all possible things which can really affect your target variable alone or in combination with other variables. Uh, the third thing is that you should take perspective from all the stakeholders. So we generally think that the data is what we have, and we generally do not have the entire view of things which can affect your target variable. And generally, stakeholders might have a very different perspective. And this is something which we have found a lot in this industry, that they bring in a kind of angle which we really cannot think of. So they can think of something which entire industry is not using, but they really think that it is true on the ground reality. So you should always take perspective from stakeholder. It should be holistic and there should be no personal bias while generating these hypotheses. So coming to that, the quality of model is as good as the hypothesis which you have created. So if you have been very exhaustive about it, and you already have covered all possible hypotheses which can really impact your model, you will generally get a very good model. But if you do not spend enough time on hypothesis creation, and now you should know that how important this is in the entire modeling phase. If you have not invest enough time, you probably will end up with a weaker model, and then you will reiterate and find out new variable which can really affect your model. So coming to my next question on survey. Kunal, can you launch that question? That what is the amount of time you think we devote for hypothesis generation? Okay. So how much time do you really think in the entire process? Say for the entire modeling exercise, you take around 3 weeks of time, but just to generate the hypothesis, what is the percentage of time you really take to create hypothesis? Come up with the exhaustive list of everything which can impact your target variable. Okay. Can we see the results? Okay. 20 to 50% is what most of them believe. 50 to 70% is okay. So what we generally recommend is that you invest the maximum time in hypothesis generation, because your model is as good as the hypothesis which you have created. That is the central idea of this slide, that your the model is as good as the types of hypotheses you have generated. And we say that because that with machine learning coming into the picture, the amount of time you generally invest in model creation has significantly gone down. Initially what we used to do is a lot of checks on correlation, and we used to do a lot of things to understand whether my model is fitting well or not. But with machine learning coming in, the amount of time now have to invest on model building exercise after you have created data and cleaned the data, that amount of time has really shrunk a lot. The data cleaning step, which is the second last step before you create the model, is also a very significant step. But again, hypothesis testing is a very critical step. So if you are trying to improve a model or you are trying to create a new model, in general, this is the time when you invest a lot and you think about all possible dimensions. So the right amount of time is generally 50% plus, and there's no upper limit to it. So I will say that if there was 70% or more, and there would have been more people who believe that, I would have not been surprised, because in general, if you are attacking a very difficult problem to solve, then this is the most important step. But if you are solving a solved problem already, again this problem is the most important step, because now you are thinking beyond what has already been thought, and you need to invest a lot of time in hypothesis generation. So 50% is 100 to 100% is what I believe is the right bucket. And I think this is throughout the industry is something which people believe, that 50 to 100%. Then the second best amount of time is on data cleaning, and the smallest window which you generally give is basically on the model building exercise itself. So given that this is the kind of importance we are talking about, let's talk about the one question which we have talked about before. So now do you really think that if you I will give you a problem in which, so we have already talked about this problem. Let's talk about the same problem and give it another shot. So we are talking about agents. The second question which I posed in this session, which is that you know that agents attrite on a very short-term basis. I want to hire such agents who stay with me much longer and are much more productive. What are the types of attributes you can look at while hiring an agent? And you cannot be something which is irrational. If you do not really think that this is something which is possible, you should still bring it up, and you can eliminate it at a later phase. But let's talk about all possible hypotheses which can impact this target variable, which is in next 3 months, who are the agents who will still stay with me, or let's say next 3 years is the right window. Over next 3 years, who are the right agents who will still stay with me. So okay, so we have previous experience with different companies, job cycle demographic and payment graph. Okay, that's good. Education level. Okay, agent performance, his network and communication skills. Okay, I think we have covered a lot of ground here. So let me break this down into those three categories which I mentioned, and I think this will be one of the biggest thing which you will take out of this session, which is while developing all the hypotheses, you should generally think of it in this way. You start with demographics. So if you want to create a decision, something like a hiring decision, when you really do not have a lot of data about agents, demographic thinking should be very strong. So does he have a PAN card? Does he so it can be really unrealistic, which you think that it might not really impact, but still it is worth checking. So what is the age band? What is the salary band? So you have covered most of them. What is the gender? Where is he coming from? Is he coming from a location which is far away from the branch? So all these demographic are something which you should really think hard. The second level of variable which you should be looking at are behavioral variables. Now, in this case, you might not really have a lot of behavioral variables, and given that I come from the industry, I might bring that bias with me, but let's not be biased right now. Again, you said that agent performance in previous companies. So any kind of behavioral attributes. I think that you have also brought out something from the third bucket, and this is again very important. His network and communication skills. So this is from the psychological part of it. So this is a third bucket where you do a psychoanalysis of that attribute. What is the communication skills? Does he have enough understanding of the business domain? So those kinds of things which might not be really objective, but they might come out of some surveys. And as of now, industry does not use it to the full extent, but now we are evolving and we are using more and more of it now. Okay, I think you get the idea. So any questions on hypothesis generation and the first part, which is problem definition? Oh, it's like playing Sherlock Holmes. You bet. So this is something which you always think that you're just investigating, and it is something which gives you a kick all the time, that you're thinking about things which are so hidden, and once you find out the actual reasons behind it. Let me give you an example, and I think Kunal will be very fascinated by that example. So the second example which I took was an actual problem which we solved, which is over the next 3 years, who are the agents who will stay with us and who will not, or who are the better performer and who are not. So these were the two different problems we were trying to solve. In the first one, we are trying to find out the okay. You are not able to see the slide. Oh, as of now, I'm not really referring to the slide. You have already covered everything. Uh, so this was one thing which we solved for, that who are the right people whom we should hire so that they stay with us more and they perform better. Imagine the best out target input variable which came out to be most predictive. It was whether he has a PAN card or not. Now imagine, we could not have thought of that variable at all if we were if we were not unbiased. We would have said that this is something which is so unrelated. But now when we started digging down deeper, we now understood that why is that important. Someone who declares his taxes is someone who is motivated in his career, and this is the strongest predictor of that motivation. We do not have anything covering that motivation part. Now imagine that something which came into our list just by chance became such a strong predictor, and we were able to understand that this uncovers a much bigger depth of the kind of profile we are looking at. So those are the kinds of problems you are solving, and that is the kind of output your models can give you. Okay, so we have something like, for hypothesis generation, domain experience is very important. That is correct, but I will always want to bring in someone in group who is giving me an unbiased opinion about everything. He knows about other industry, and there are something which can be leveraged here. He can be a big asset, and I have always found that to be true. How it happens in the real office? Oh, it is something like you sit in a room with a whiteboard and you have like 3-4 colleagues or your team members, and you start thinking about all possible things which can really affect them, and you can come up with very random and absurd ideas. You think that they are vaguely related. So it's not like you are bringing out all unrelated objects should not be a part of it, otherwise you will waste a lot of time. But if you think that there's something which is vaguely related to your target variable, you should bring that up. And in the whiteboard session, we draw out all possible things which are possible, and then we try to derive out new things out of it. All things which you already have on the board, you try to derive out things out of it, and then you create variables out of it. So that is how it really happens in a real world scenario. uh, so here we had a list of things, and you already have come up with all of them. So we had in this particular problem, we had 4 hypotheses, which I think we already saw on the screen. One is income, whether higher income means higher chance of financial stability. So even though here you have some sense on where this variable can take you, whether it will have a positive relationship with target variable or negative. Even if you think that some variable is important, but I do not know that direction, that is still a good enough reason to bring it in the hypothesis list. So the second one was a job type, what kind of job type he had. The third one was credit history. Again, one of you did say what is a credit history, what is a CIBIL score, FICO score. Education background. This is again something which came up to the group. So I think the group has now a good understanding of what the hypothesis generation is. So in the next few slides, I will cover up some other parts of the process quickly, but I want you to understand these 2 steps very well. So before you get into this industry, if you are trying to get into the industry, these are the 2 big things which you will check about you. So are you able to find out the right problem to attack? And are you able to create the right hypothesis which should be tested? And in hypothesis generation, if you are creating crazy ideas, that is never counted in against you. If you have a reason to believe that it can impact it barely, then also I'm bringing that into my list. And I think that you are adding a new dimension. That's a good thing here. Okay, so there are a few common questions which I will answer here. I have someone. Can we consider social media behavior? Oh wow! So this is a very good question. So social media behavior variables are very important. As in, we have found them to be like the gold mine. We never used it before, but now we have started using it. So beyond social media, now what we are using is call center data. So in call center, we have transcripts, and using those transcripts, we create features using NLP and a more complex algorithm, which we might be taking up in some of the few sessions to some extent. But there are a lot of algorithms which can create features out of them. So free text, social media free text, or the call recording, or any kind of unstructured data are very strong predictors as well. And the reason they are so important is that most of the models now are incremental in value. So you have already created some model and you want to create a model which performs better. And to make something better, you should focus a lot of effort in this hypothesis generation phase. And in this hypothesis generation phase, you should think about non-traditional variable which can come up. So social media is one of them. Another can be call transcripts, or yet another can be your feedback or your clickstream data. So all these unstructured data will be very important once you start creating a model on top of something which is already pre-existing. So, okay, I have another question. Let one person may have differently. I'm not sure if I follow that question correctly. Can you type that question again, Sai?
So I think he's asking that one person may behave differently on different social media platforms. So I might behave differently on Facebook than on Twitter than on LinkedIn.
Oh yeah. Okay. So I think that's what. So that is on hypothesis testing phase. Now you are talking about whether this variable will be important or not, whether this collection of variable will be important or not. So the question right now is whether it's important or not, whether it is actually important or not. The question is just to create hypothesis. So if it is, they are behaving differently in different platforms, we'll take input from all those Facebook feeds, Twitter feeds, all possible feeds which we have exposure to, and for which we can create data for all the target customers that are in focus for the current modeling exercise. Okay. So as of now, we will focus more on hypothesis generation, and some common question which we generally face is that should hypothesis generation be done? Okay, this is something which we already answered. Hypothesis should always be
Ramesh,
done before. Okay,
there are
sorry.
a couple of questions on the Q&A window. I think we can take them as well. If you click on that, you should be able to see it from your
Yep.
interface.
Okay. What is the best and okay,
So this
what is
we
the
can
best
take
way and
later,
resource?
Aryan.
Okay, yeah, we can take this one later. Do we always have a good or bad problem statement, or only good? Okay. So in terms of problem definition, you should create a specific problem. If this question is on problem definition, you should really talk about one problem definition which can really justify your business logic. So if there is are more problem definition, for example, for the agent example which I took, we were focusing both on their behavior after they onboard and whether they will stay with us or more or less. Generally, these problems are much complicated to solve because there are two dimensions on which we are trying to optimize. So in general, you will only focus on the most optimum problem which suits your business objective. I hope I answered that question correctly if I understood that question. Suvarna. Anand says that can you okay you okay banking sector. Okay, so as I said something on Amazon. Let's take a very simple on Amazon. It's more about say recommendation engine. When you talk about a recommendation engine, let's talk about one single product, whether this product is suitable for Mr. X or Mr. Y. What we generally do is that say you have a list of customers and you know their buying patterns, and you exactly know that whether this person bought a specific product or not in a 1 year window. So this is one problem which you can solve, which basically can be aggregated to a recommendation engine. Or second example which I can take is from say call center industry. So something which I have worked on lately, which is the basic question which we were trying to solve was that what is a customer really calling me for? Why is he even calling me? So the business problem was very absurd, as in I don't even know what I'm trying to optimize. So we did a lot of digging around what is the right business problem to be solved here. So we then found out that the right problem we are solving for is call reason. What is the actual call reason? And if I can predict that call reason, I can deep dive into that call reason and find out what is that real problem which a customer is facing, uh, which falls into this call reason one. So that is the kind of problem we are talking about in operations industry. If you are talking about something like pharmaceutical industry, you might want to so in pharmaceutical industry in general you are doing a hypothesis testing, but in case you are trying to find out for a particular insurance plan, what are the right target customers whom you should target, and your target variable here was say profitability. So if you have a lot of data and you see a particular cohort on a 1 year window, what is the total profit which a customer has generated? That becomes your target variable, and you try to optimize that. And if you find out the top 2-3 deciles which have a very high profitability, let's go behind them. So those are the kinds of problems we are trying to solve in different industries. Okay, let me take another question from how much is the percentage distribution of domain knowledge and technical knowledge to generate good analytical model? So I think we will take that question slightly later. How can we generate hypotheses without business understanding? Okay. So obviously business understanding is important to some extent, but generally when you are creating hypothesis, you can be as newbie as you are. So any problem which you are trying to solve, everything is can be connected to your personal level to some extent. So if there is a problem, say I'm solving for whether a particular agent is able to perform better in an insurance industry or not. Let's take the same example. Now, even if you do not know anything about insurance industry, you still should be able to find out those specific things which can influence that behavior, and then you should do a research around that specific industry, that what are the additional variable which you can bring in now to add to it, that list. So it's not mandatory that you know A to Z for that industry to create these hypotheses, but you can start this process even without knowing anything, but you certainly have to evolve in that direction, that you start that market learning and then create a exhaustive list of hypotheses. Okay, so in interest of time, I will go on to the next phase, which is data extraction and collection. I will pause after taking all these for all the questions which you have. So I will quickly cover all the next steps quickly, just because that these will be part of our next session as well. So in terms of data extraction and collection, so once you have the hypothesis set, you already know what target variable you are trying to optimize. You already know that what are the input variable you will be using to make that prediction. Now, in terms of data extraction, you now go to all possible uh, ways you can collect data to justify those hypotheses. And these can come from anywhere. So, for example, demographic. So, in terms of demographic, there are third parties which you can go to, or there are a lot of things which you already fill in the form. So, those are the demographic data we are talking about. So let's take one example just so that we understand these concepts quickly. So I'm looking at, say, the agent behavior. So when I'm trying to hire an agent, I'm trying to hire an agent who will stay with me for more than 3 years. Now, when the agent fills the form, he writes his demographic, and all those data are already available to me. So I can put this data into my model and try to predict what is his likelihood that he will be staying with me for more than 3 years. The next is transaction history. So behavioral variable is not very important here, but the kind of behavioral variable which we can look at here can be something like what is his past experience. So how did he perform in his last company? You might not have really visibility into it, but if you can get that through some sourcing company, or now you have to think about different sources which you can get to collect this data. Other data can be payment history. So for the cards example which you saw before, payment history, transaction history are these kinds of behaviors which you need to capture. The third party kind of variable can be credit score, FICO score or CIBIL score, which can impact someone's default rate. So that is the kind of data you are talking about here. So there are these all types of data which you can collect together and bring them into a single structured data format, where you have input variable and you have an output variable. And that is a data collection step. You go to different sources and you collect data and create a single table, and your machine learning model is able to understand this data now. I think I have a question here. Okay, we can share a few more problem statement. Let's just go through this entire process quickly, and then let's talk about a few more examples where I will just take you quickly through all the processes which we went through. So this is the data collection and extraction phase. Then next is data exploration and transformation phase. So when we used to create logistic and linear models, this used to be a very critical step. But with machine learning evolving a lot, that amount of time you spend on this stage has significantly gone down. It is still one of the most significant attribute where you are trying to create new features, but still this has significantly gone down, because now addition, subtraction, those kinds of variable are already being created in terms of the transformation when you create something like a random forest or any kind of machine learning model. So that was a very significant step before. Even now, for feature engineering, to some extent, you have to do data exploration and transformation. Exploration is still an important step, but transformation is still a lesser important step as of now, as a lot of things has been already done in the framework which has been created for you in terms of machine learning. So in this data exploration and transformation phase, this is the kind of cycle we generally follow. You identify all the variables. Now you do a exploration of this entire data. You try to find out univariates to understand whether there is enough variability in your data or not. So if a particular, say, variable has only 5% values as 1 and 95% value as 0, then probably the amount of variability which the variable has is not good enough to justify any kind of behavior. So, and hence you generally will drop this variable if you think that you are using algorithm which might not be able to take so many variables at a time. So then you do a univariate analysis to understand what is the kind of data you are really looking at. Then you do a multivariate analysis. So multivariate between input variables. So you might want to observe whether input one variable is able to justify target variable to some extent or not. You might also be interested to know that how is input one related to input two variable. And this relationship can really be exploited when you are creating a feature. So you do a lot of multivariance, and here is when you do a lot of, you understand the data thoroughly. How is the data really varying across different customers or different attributes? Uh, then you do missing value treatment. So now there are a lot of ways where we do a missing value treatment, where you can create a default option, you can substitute everything with the default option, or you substitute with a mean. So there are a lot of methods to do this missing value treatment, which we will be covering in our successive videos. uh, but this is again a very important step, because most of the algorithms do not understand missing values, and hence you are a better expert to make the algorithm understand what the missing value really means. Is it a separate category altogether, or uh, there is a smarter way to basically impute that data? Then you have an outlier treatment. When you go to outliers, this can really skew your model, and hence you want to constrain it by capping it or flooring it, and you do a lot of steps to do outlier treatment. Then you'd finally do a variable transformation. So initially, this, as I said, that this used to be a very important step in our entire phase when we used to create logistic and linear regression 3-4 years back. When we used to create sine function, exponential series, log function of a particular variable, say the income band is a huge band, say from $0 to $1 million, and it becomes slightly scattered when you go to higher bands, and hence a log function of that income variable makes more sense. And when I see a bivariate of that variable with my target variable, it makes much more sense using the actual original variable. So we used to spend a lot of time on variable transformation. However, with machine learning coming in, a lot of transformation are already taken care of in that machine learning model. So this is data exploration step. The next is the predictive modeling, and I'm going faster because just in interest of time, I will cover all these, and then we will go to questions. And if time permits, we will go through a very simple problem and go through all these stages, saying that this is what we do in this stage, this is what we do in stage two, and this is how we proceed. So in predictive modeling, what we really do is, it, as I said, that it's a process to create a statistical model for estimating, predicting the future behavior based on all the past data which we have. Now, we have already gone through this a lot of example, but what we really do is that, say, your percentage of response rate of the entire population lies behind something like, say, 0.1. Now, what will a predictive model really do is, it will go on a customer level and it will try to move this needle. The green dot which you see here, it will try to move this needle for every customer based on all the behavioral patterns I have on this customer. So if a customer is belonging to a behavior which resembles a lot with someone who has a much higher response rate in past, it will basically move this needle to a much higher value above 0.5 or towards 1, or it can move the needle below. So what it will try to do is, it will try to segregate out good from bad. So if you take out any kind of performance metric, if you want to take a random guess on probability, the best guess is always on your mean. But when you start creating better and better models, this needle will start moving more towards 1 when it is a good value. But if you have a bad model, obviously it will move on the opposite side. But if you have a good model, you will get much more extremer values when you have a much stronger possibility that someone is a good or a bad, or a responder and a non-responder. So this is what a predictive model really does. And we will cover this in much more width and depth once we go to our next session. So coming to the last phase, which is model deployment and implementation. Now, even though we generally ignore this step and we think that our work is already done after model building, uh, in actual scenario, that's not the case. Your actual battle starts after you have created that model. Now you have to sell that model and you have to deploy that model in the right way. Firstly, you have to identify the right levers through which you will be applying this model. So for instance, what we did with the hiring strategy was something like, there was a application fee for agents when they used to apply. What we did was we started varying these application fee, and the application fee was much lower for people who were much higher performer. And hence, in our application itself, we started getting a lot of application from those customers, from those agents who were much likely to attract less in next 3 years. And hence I was able to manipulate that application pool itself, and further we were able to get a better mix in our actual agent hiring pool. So that is how we create a lever. Now, managing this fee or creating this fee structure was a lever which was developed after the model was created. Now that is when it comes to implementation, and that is when the actual artwork comes into play. Till now it has all been science. There was some artwork before when you were developing variables and when you were basically creating a target variable, but after that it was all a structured process. But here is where you have to think about everything. Now you have to understand the business. There is no doubt that you need a to z understanding of business to create this step, which is what is the right lever which you need to use to basically implement your model on the field. So this is when the implementation and deployment comes into play. Uh, so this is one of those example where you have building recommendation engine for an e-commerce company, and the right way they are trying to target is through that recommendation tab. So that is a lever they are using to implement that model on the ground. Okay, so model deployment again. So for face recognition, this is a much easier problem to solve in terms of thinking out what is a lever, but in terms of deployment and implementation, it is a much challenging process. So again, this is another example where you are trying to detect a face, and here you can imagine the kind of data which goes in. The pixel data is the input data, and you are trying to train on a lot of images. Where do you really see a face? And you need a box there, and hence your machine will try to learn from all these patterns, and it will try to find out where is that similar pattern in this new photograph, and then you have to basically deploy that on a mobile camera. So that comes into the implementation phase. Even though your work might not really be a lot in terms of implementation of it on the ground, but your work will be a lot in terms of identifying what are the right levers and whether the implementation was done in a way you intended to do it. Otherwise, what I've seen a lot in this industry is that you do a model and you say that this is the predicted values, and it gets implemented in a way which will have much less impact than you really thought of. So you have to be so much more involved in that process to understand whether the implementation was done in the exact same fashion as you visioned in beginning of the problem. So these are the different examples which comes on deployment and implementation. And let's now focus more on questions, and then let's take one example and let's just follow through what are the various steps. And I will want more participation from you all in terms of what are those unique steps which you need to go through to crack that problem. So any questions till now? Let's just take up question and then let's quickly move on to a single problem. Okay, I have a question which is hypothesis like binary always? Okay, now that's an interesting question. So what we have generally seen on ground is that logistic regression or any kind of binary analysis generally have a much more predictive power and stability across field. So for example, if I want to define what is the profitability which was generated by a customer over a 1 year rolling window. Now, there are two possible ways we can define the problem. One can be that whether that profitability is more than my average or not, the current average. This is a binary function. And the second can be what is the total profitability he generates over a 1 year window. Now, if you think about these two cases, Both are perfectly logical target variables, and you can really take both of them. But what we have seen through experience is that binary variables are a lot stable with time. So one thing which you will generally see is that there will be a stability criteria. You will have a PSI or something which is a population stability index, which come out to be so much more stronger in binary variables, and hence in general you will see a binary variable kind of problem. But it doesn't constrain you at all. So you can really take in a continuous variable as well. But if possible, you should take a binary variable because it helps in kind of population stability and all that. But it doesn't constrain you to not going to something like which is much more continuous. Or you can also have like multi classes variable. As I said, that one problem I have been trying to solve is that what is the right call reason a customer is calling for. And when you think about call reason, it can be to make a payment, it can be for billing issues, it can be for so many different call reasons. And I try to create a model which will try to predict any of these classes. So this is a multi-class problem we are trying to solve. So this is as good as a binary variable. Whenever you have classes, you generally have a very strong PSI or a population stability. But when you go to a more continuous variable, you have to create a much stronger model to find out the stability, and you might have to compromise on the predictive power of that model just to make that model more stable. That is just through my experience, but it's not something which is a hard coded fact. You can always go to different types of variables. So how a free text field could be used independent variable in any linear model. Okay, so free text, as I said, that say if you are trying to predict the call reason when a customer calls your call center, the free text available is basically the transcription which comes out from the speech to text kind of conversion. Now what we usually do is we use something called NLP, and we try to create features out of that free text. Now this free text can be a single word, which generally we have seen does not have a lot of power. But if you go to phrases and if you go to combination of phrases, these become very strong. And whenever you see that phrase, you will turn a variable 1 or 0. So for example, if I want to look at customers who are very angry with my card, and I am looking out for a say phrase which is close my account. Now whenever I will see close my account in the entire transcript, this flag will become 1, else it will become 0. Now this variable, which is 1 0 variable, will become a input variable to my target function. So that is how you use a free text as a independent variable. I have more questions here. Okay, how to choose a suitable feature for business problem. Okay, uh, this is not a part of hypothesis testing. First of all, this is a part of the next step which we talked about in terms of feature selection. We will cover this in much more depth when we go to the next topic. But for now, what I can say is that to select the suitable feature, what you generally do is for different kind of technique, you have different kinds of feature selection process. So for example, a very simple example is that if you are creating a random forest, it will automatically give you a feature importance, and you can select the top important variable to go into your model. So that is a very simplistic way, but there are so many easier ways to select a feature. There is something called IV score. There is something which is called correlation matrix, through which you can select which are the variables which are highly correlated, and let's ignore all the variables which are less predictive but highly correlated with a variable which is highly predictive. Okay, so that is something which we will go in much depth. So wait on to that question. We will come to that again. You mentioned close my account, but what happens if user writes do not close my account? Oh, that's a very good question. So as I said, NLP is the kind of algorithm which we use, and why NLP became important was that say close my account is a metric which we are trying to track, but do not close my account is also a metric. So what we can do is we can create both these variables. One is if you see close my account, say 1, and the second variable is if you see do not close my account, then you again say 1. So if you have both ones, then you probably know that it's not to close my account. And if you say only close my account as 1, you know that it is to close my account. So now you have created two features to justify this logic when you have a negation statement, something with not. And This is a very simplistic example, but when you see Google and all who are trying to read your mails and they give you exactly the right suggestions, what they are trying to do is that they have trained neural networks which can work in a way in which a word which is far away from the second word can really influence each other. So if you have something like, I am not calling you to close my account. Now, not as so much farther from closing my account, right? And in NLP algorithms, normally you might not be able to capture it because it's not a single phrase. But neural networks can be trained in such a way that it can capture such difficult grammar language as well. That when you have negation far away from the keyword of this entire sentence. So we might not really go in depth of it, but there's something which we are able to tackle now. We were not able to do this something like 2-3 years back. Google might have done that at that point as well, but this is something which we get everything which comes to Google first comes to us like 2 years later. That is how this industry has really evolved. Do they consider the prior words also? Yes, I actually answered that. Are we going to cover random forest and neural network also in the data hack R? Kunal, do you want to answer that question?
So we'll not cover neural network. We'll cover decision tree, which is kind of the founding stone for random forest, and we'll give resources so people can then take it from there. So by end of data hack R, you'll have done linear logistic regression, decision trees, and KNN models, and you'll have resources for doing other algorithms.
Okay. So I think these I have answered all the questions. In case you see any questions, do let me know. So let me go ahead and take an example before we close. So let's go to all the steps which we discussed before and take an example which is very common in the industry. It might sound very familiar. So for example, in credit card industry, we have a problem which is called credit line increase problem. What we generally do is whenever you take a credit card, you get a credit line of say 50,000 rupees. Okay. Now I want to target people so that they get a higher line or increase their credit line and they reach 1 lakh rupees or from 1 lakh to 2 lakhs. And I want to find out a segment of customers who might be interested with this kind of offer. And say as of now you have something like 1 million customer who sits on your portfolio. You can only give this offer to say 10,000 customers. So that is the problem. So what is the response rate of, sorry, what are the right customers you need to target so that they take up this offer in a next 3 months window? So I have already done the first two steps for you. First step for you, which is problem definition. Now we will go to the hypothesis creation phase, when you will come up with all possible things which might influence this problem statement, which is what is the right customer base which I need to target, who will basically accept this offer of a credit line increase. So what I will do is I will create a lot of hypotheses around. So give me a few hypotheses. I'm just looking for 2 or 3 hypotheses which might influence this behavior, which is that a customer will respond to a particular campaign in a credit industry, which is a credit line increase. You might want to think more on your spending patterns or think about yourself. When will you need a credit line increase? Just put yourself in the customer's shoe and think of yourself as a customer who will want a credit line increase. Think of all the situation which has led you to that stage. Okay. So salary hike, amount spent on the credit in last 3 months, number of transactions. Oh, great. During festivals. Okay. During festival is not a customer specific. So I will need more on customer specific behavior. New goods. Okay. Or some functions like marriage, when my monthly expense exceed. Okay, great. So I have a lot of hypotheses, so I need not develop more hypotheses, but you already get an idea that I have gone through a hypothesis generation phase. Now after this phase and before I go to the next phase, generally there is one thought which I generally take into account, that what is the granularity level on which I am going to build a model. So here my granularity level is a customer level model. It can be a segment level model. It can even be a more granular level model. For example, in operation industry, we might go to a call level. So a single customer is calling you multiple times and I want to take a decision on a call level, and hence my granularity goes even down to a call level. So here my granularity sticks to a customer level, and hence my hypothesis should always be to do something with the customer. And thanks for reminding me with that one variable which you brought up, which is beyond customers. So if your granularity level is customers, you should think everything around the customer. Okay, so once you have that hypothesis created, now you will go to a data extraction or collection phase. Now you have talked a lot about behavioral variables. So this is something which you have collected over years for a cards product. So you exactly know how much a customer spends. You exactly know how much, what is the revolver rate of that customer. You exactly know the different types of products he buys, or you exactly know what kind of loans he has with your company, obviously. So these are the behavioral variable which you will already have in your in-house data set. But you have to go beyond that. Now in your hyper generation itself, you have talked about something like a risk score, or something like what is the spending pattern which can go beyond your card. So for instance, I use City card only to make purchases in grocery, but when I am buying a car, I will take a Chase card. So if I have a exposure to the complete behavior, I will be building a better model, because now I am capturing a customer as a holistic customer. So now I will go beyond my in-house data to something like a third-party data, which collects data from all the sources. So that becomes my FICO score, that is my CIBIL score, that is my spending pattern on other cards, or something like what other loans do I have beyond Citibank, right? So those are the kinds of behavior we can capture from the third party data. Something which now I can see is survey data. So I think someone brought up something on psychological behavior. So if there has been an NPS score, that will you like to recommend City more? So then if he says yes, probably he might also be interested to increase his limit on City card and not on Chase card. So you can look at psychological or psychographic kind of variable, which is something to do with much more subjectivity or the value of the customer. So those are the variables. Now you can also go on your feedback, that you on City online page, there are a lot of feedbacks which come from a customer. They are saying that I'm not getting a credit line increase, or something which is related to that. So you can go to that free text and bring that into your data. Or something like, you can go to Facebook or you can go to Twitter. You might not really get a lot of value from those data, but it is definitely worth exploring. Or something like a network data, that who is he really connected to within City on Facebook. It's a very random thought, that if that other person has a higher line, this probably person will be influenced by that person, and hence he will be looking out for a credit line increase. I know it sounds absolutely absurd, but it is worth exploring, right? It is a possible variable which can influence, and you should include that in your hypothesis generation stage. So we are looking for any kind of absurd idea which can influence. Uh, so data collation and extraction is what happens now, that I go to various data and collect all the data. Next is data exploration. Now is when you kill down a few variables. So if you see a few variables which are coming of no value with the target variable, in combination with the target variable, or some variable which does not has a lot of variability, you drop them. And we will talk this a lot more in our coming sessions. But this is a data exploration and transformation phase, that when you select a few variables and transform a few variables and basically come up with the exact list of variables which you want to put into the predictive model, which can select variables further, but this is the variables which you think are highly predictive. Now you will go to the predictive modeling phase, when you will think of a way you have to model. So you can use different techniques, you can use ensemble modeling, and then you can basically come up with a prediction on a customer level. Because as you discussed, on the second level, you said that customer level is the most granular level I'm going to make a prediction. So customer level prediction is what you will get out of the stage 5. The next stage is the deployment and implementation. Now you have to think of the right lever. You already know the lever in this case, that you have to do a campaign. Now you have to think of different methods of delivering this message to the customer. So with all the highly predicted customer who are predicted to be goods, now you have to think of right channel to reach out to them. So for instance, the ones in the top 30% which you have predicted, you know that their response rate on direct mail is much higher than any other channel. However, for your entire portfolio, this was exactly opposite. And hence now you know what channel you should use to implement this model. So that comes in the last phase when you are deploying and implementing that model. And finally, you deploy that model and then you start monitoring whether your model really made sense in the real world. Because even though it looks good on books, some models fail on actuals because we were not able to capture the behavior in the exact way it was supposed to be. So you start monitoring on a 3-month window, 6-month window, and try to find out whether your model is working or not. So now coming to questions, this is how the process will really look like in a real world scenario. Okay, so do you have any questions on any of the 6 steps, or any kind of suggestions for the next few lectures? So this is where we will close, and if you have any questions, you can put up now.
Tavish, there was one question from Arihant on what is the best way in resources to improve structured thinking. I think we can take that.
Okay. So yeah, so in terms of best way to and resource for structured thinking, the best point to start is definitely a lot of blogs which we have published on structured thinking. We have talked a lot about how you start thinking in much more depth, and how can you structure your thoughts and basically break down a problem into much smaller pieces and then attack each of these problems. Once you get comfort with them, then there are a few books on structured thinking which we have already published on a few articles. So the best point to start are a few articles on structured thinking, and then a few resources which we have already published on our blogs. But to get a feel of it, you generally should start using that structured thinking in some kind of real world case. So how I do it is that, for instance, I get Google Maps prediction every day. Now just stay and think about how can you really break down that problem into much smaller pieces, and where you can define a specific target function, which can be a binary variable, which can be a multi-class variable, and then with a series of prediction you can roll up a prediction which a Google map does. Even though you might not be able to make the actual prediction, but what it will really help is, it will really help you create that process in which you can start doing that structured thinking. So use those resources, read them first, then start solving some real life problems. So even though the data hackathons, they will lack one big thing. We will have already defined the biggest thing which you will face when you come to the industry, which is problem definition. A business person will never come to you with a specific definition that you have to optimize me campaign who will respond to you in 3 months. No one will come with. Someone will come to you with a very absurd problem, and you have to think of a very structured way to break it down, whether it's a single objective function or a multi objective function you are trying to identify. If you have gone to that depth and you know that those very specific things which you are trying to optimize, then you have to go through this entire step by step approach to create models. But to develop that structured thinking process, I definitely recommend you to take a few problems which you see on a daily basis, think of it from a customer perspective, how it helps you, and then think of it from a Google perspective, or whoever has developed that app or that tool, that how do they really design the solution, which might be a single prediction or which might be a collection of prediction which is being shown to you in a very simple way. So that is how you should really start with this structured thinking. Start with the documents and then go on actual problems and just think out loud what you can really break down that problem to, and finally solve that. A rough estimate of, say, Google Maps or a weather estimate, even though you might not have the data to simulate it, but you would have already broken it down, and you would have already enhanced on the process which you go through when you're doing a structured thinking. Okay. I think not always we have good problem statement. Oh yes, you never have. So it's Not always, it is always not. You always not have a problem statement, and a business will always come up with you with a very ambiguous problem, and then you have to be smart and think about it in a structured way, what you have thought through in different cases or through your experience, and then you have to create or tailor a right problem statement you want to solve. Okay. Then we have dimensionality reduction is very important. uh, and but you said, okay. Okay,
I
I'm not
think
sure if I followed the
Tavish, the
question.
question is basically so we said that people should add as many hypotheses as possible, and which might lead to more dimensions and duplicate dimensions coming in. So the
Right.
person is saying that how to handle that and how to solve that.
Okay, how to solve the number of dimensions? Okay, so generally you start with a lot of dimensions, as we said before. You come up with all possible things which can impact, then you start collecting data. Now, when you are collecting data, you don't have to restrict yourself with what you have. You have to think of out of the box that how can you really create that data. If you're not able to create that data, you already have the first cut of elimination, that you start with say 1 million variables and you finally find, say you are able to find out 2000 or 5000 variables. You have already done a first level of elimination, which is dimensions have already been reduced. However, you should go beyond to find out if you can create more variables, but if you cannot and you do not have enough time to explore further, you already have 5000 variables. Now you do some initial testing, univariate plots, bivariate plots, and you try to find out which are the dimensions which were important. And if you cannot use all these variables together in a machine learning model, you should start doing dimensionality reduction there. This is really dependent on the kind of hardware you have. If you have a huge machine, you are doing it on Hadoop, and you are using H2O packages, and you are already using a distributed algorithm, you might want to use all the variables together and find out which are the variables which machine throws up, that these are important, and then you start going on the process again. But in case you do not have that kind of uh, hardware, then you probably want to shortlist it to some extent using all the logics you have. You, as I said, univariate, bivariates, and then you have something like you can run a very simple random forest and you can do a dimensionality reduction there. And there are IV scores, and then you have VIF factor, which you can develop through a very simple logistic function. So there are a lot of dimensionality reduction tool which we will cover in future, which are apt for different techniques. So if you want to use a random forest, you don't really care about VIF. But we will talk more about that. But there are a lot of techniques which you can use to reduce these dimension if you do not have the right hardware to attack that problem. Okay, going to the next question. Are there any tools to perform model deployment implement? Oh wow, that's there are no perfect tool which can help you with this. And this is where I will want. So if I am hiring someone, this is where I want creativity. I want a person who knows the industry really well to help me out with a very creative way to design a solution which can be used to implement this logic on the ground. So this is a very key differentiator between someone who has developed that structured thinking approach versus someone who has not. So this is one thing which you definitely need to think about. There are softwares available, but I have never seen a software which is perfect for all possible scenarios. So this is something which you definitely will want to practice and know that how can you really do it. And for this you definitely need to understand the industry really well and your company really well. So yes, for this you do not have any tool which is apt for every kind of problem. How to choose best model if we get different answers from different algorithms. So this is something which we will definitely cover in our future sessions. And we will talk about what are the different approaches, and we will want to uh, narrow it down to two or three approaches, and then we probably want to get to one, or we can create an ensemble model. So those are things which are left for our future discussion. This was just a preliminary discussion on how do you really go about this journey, and what can you really imagine yourself doing if you land up into this kind of role? So can model deployment be done by Django? Okay, so I will not want to take that question. So Kunal, do you want to take that question? I do not really have that answer.
Yeah, well, already answered that to Ashish privately anyway. So yes, it can be done through Django. So for those of you who don't know, Django is basically a web development framework. So if you're using Python at the backend, you can integrate the machine learning algorithms if you've written them in Python. Call them through Django. So these could be your functions or views depending on how you want to do it. So just to give you a few examples, so the job recommendation engine running on Analytics Vidya on the job portal is deployed through Django. So that can definitely be done.
Okay. Okay. Uh, any other questions?
I think we have overshot the time, but thanks a lot, Tavish, for that session. I think that just sets the tone for rest of the upcoming sessions really well. So if there is one session you should have attended, it was this session. And one thing which I forgot mentioning upfront. So this is such an important topic that when Tavish joined Aviva, I think this was one of the first things which I kind of explained to him. So it's kind of a reminiscent of some of the past days. So that's the
And
kind of journey you would go through. So make sure if you've missed anything, if you joined a bit late, go through the recording. The recording would be shared with all of you. And then even though it might feel that it was not a technical session today, believe me, this is probably more important than anything else. Tavish, you were adding
yeah,
something.
yep. No. Thanks a lot, everyone, for bringing out so many questions. And I think you were already there when I started asking you what are the possible hypotheses and all those questions, and you already had that knowledge. So you generally do not need to be an expert into analytics to basically start thinking of those few initial steps. So if you think about it, the first three steps you talked about, it has nothing to do with modeling. You just have to enter into that customer's shoes, and you have to just think of it that if I was the one who was being targeted, what would I be doing? As in, what would have been the circumstances which brought me into this position? So it has nothing to do with analytics. It has just to do with your creativity around, and this is something which can never be automated. Machines cannot take over this piece. Machines have really taken over a lot of the later part of it. That where you start doing machine learning, you throw out objectives, and machine gives you results. But when it comes to the creativity of the first three parts and the last part, which is on deployment and implementation, it is all human beings who can do it. And I hope this session helped you at least give that nudge to you to basically start that process and think about different kind of predictive algorithms which you encounter on a daily basis, uh, and think about how are they really doing it. How can you really break that problem into a, imagine that you were given that business problem that as a customer I need a Google map which can tell me the exact time I will take from my office to my home. Now, if that is a problem, how do you really structure things around it and find out a specific business objectives which you will be solving through analytics? So thanks a lot, everyone, for being such a patient audience. I hope this session was productive. Uh, and definitely I will want urge you to join all the future session because it is just in continuation of what we just discussed. This is just the starting point of it.
Right. So as Tavish said, make sure that you come for this 1 hour daily, and that's the whole idea behind doing DataHack. So tomorrow we'll start at 9 sharp. You'll start getting into hands-on some basic exercises with Python and installation of Jupyter notebooks. So we'll see you tomorrow at 9 o'clock. And if you have any feedback, feel free to share it with us, and it would help us kind of make this better for everyone. Thanks a lot. Thanks a lot, Tavish.
Thanks a lot, Kunal. Thanks a lot, everyone.